Hello students, today we will discuss about limit of a sequence, convergent, divergent of a sequence. So let us see, first limit means when you are taking any function, then apply the limit, then it is as extends to 2. So it is nearby 2, then the functional value is nearby 4. That means what? It is reaches to some value, then the functional value also reaches to the nearby value, that is 4. So in the sequences, suppose one sequence we are taking, but for any sequence always we are taking as n tends to infinity, because we know that sequence is from natural number to real number. So domain is natural number, so obviously it is reaches to infinite, then the sequence value may be either finite or infinite. So limit n tends to infinity, Sn is equal to L, in the sense limit value of Sn, it reaches to nearby value L. So here convergent of a sequence means take Sn is any sequence, then when it is convergent, in the sense limit of the sequence should be exist and it should be finite. That means when you are taking as n tends to infinity Sn equal to some finite value, then we can say it is convergent. Suppose here we are getting some infinite value, then we can say it is divergent of a sequence. Now one sequence is given, check whether it is convergent or divergent, then what we have to do? First of all, apply the limit. Apply the limit in the sense no need to take every time as n tends to, what is the answer, what is the limit value means always as n tends to infinity, because here sequence means domain is natural number, so always for any sequence we are taking limit as n tends to infinity. Now what is the sequence here? 1 by n. As n tends to infinity, 1 by infinity is nothing but what? 0, which is finite. So here the limit value is finite for this sequence, so given sequence is convergent. Similarly, we can do another problem. Sequence is given, then to check whether it is convergent or divergent, we need to apply the limit. So for this, as n tends to infinity, n plus 1 is also tends to infinity, right? So n tends to n plus 1 tends to infinity, in the sense when you are taking the reciprocal of infinity, then it will be 0. So here what is given? 1 by n plus 1 whole cube. So obviously it is also tends to what? 0. Now limit, now here limit 2 into 1 by n plus 1 whole cube here. So as limit 1 by n plus 1 whole cube. So 1 by n plus 1 whole cube tends to 0, in the sense here 2 into 0. 2 into 0 is nothing but 0, which is also finite. So it is convergent. So another one, 1 by 1 plus 2 by n. So when you are taking the limit as n tends to infinity, 1 is 1, and limit n tends to infinity 2 by 1, 2 by n. Obviously again as n tends to infinity, 1 by n tends to 0 means this value is 0, and this value is limit of any constant is that constant. So 1 plus 0, that is 1, which is also finite, so it is convergent. Similarly, we can learn divergent of a sequence. What is divergent means? It is limit value is does not exist. Suppose limit value does not exist, then we can say it is divergent. Limit value exists and it is a finite value, then it is convergent. It does not exist, in the sense it is divergent. Let us see. Take n. As n tends to infinity, for this sequence n, obviously as n tends to infinity, n value is infinity, so limit does not exist here. That's why it's divergent. Similarly, we can take another example. It is also what? Divergent. So see here, null sequence. Null sequence in the sense, suppose when you are taking a sequence, apply the limit, then the value is 0, suppose, then we can say the given sequence is a null sequence. For example, 1 by n. When you are applying the limit as n tends to infinity, what will happen? 1 by infinity is 0. So obviously it is a null sequence. So obviously what we can say, null sequence is a convergent sequence, right? So write the first 5 terms of the following sequences. So write the first 5 terms. So already we have discussed in the previous video, like when you are taking any sequence nth term, then to find all the sequence elements, what we need to do? Substitute n equal to 1, n equal to 2, n equal to 3, because sequence is an mapping from natural number to real number. So in the domain we are substituting this one, then we are getting sequence elements. So 1 by 3 into 1 plus 1, that is 1 by 4. Similarly, we can substitute all those values. So here it is asking that first 5 terms. So this is first term, second term, third term, fourth term, fifth term. So first 5 terms we have written. So similarly, Sn equal to 3n plus 1 by 4n minus 1. Similarly, substitute n equal to 1, then we are getting 4 by 3, n equal to 2, then 1, n equal to 3 means 10 by 11, like that we can find up to 5 terms. Similarly, here also substitute 1, 2, 3, 4, 5, then 1 by 3 power 1, 1 by 3 power 2, like this will come. Okay. See this problem, already we have discussed in the previous video how to find all the trigonometric value above 90 degrees. So see here, sin n pi by 4 is given. When you are substituting n equal to 1, then what it will be? Sin 45. We know that sin 45 is 1 by root 2. So similarly, n equal to 2 means when you are getting here pi by 2, sin pi by 2 means 90 degrees, that is 1. Sin 3 pi by 4, that is 3 into 45 means 135. 135 we can write as what? 90 plus 45, or else you can write 180 minus 45. Now 90 plus means it is in the second quadrant, right? In the second quadrant, sign value is positive, that's why we are taking here positive. And 90 means sign changes to cos, so cos 45 is 1 by root 2. Similarly, here this is sin pi. We know that sin pi is always 0 for any n. We know that sin pi, n pi is always 0 for all n. Suppose you are taking n equal to 1, 2, 3, 4, whatever you are taking, sin 4 pi is also 0, sin 100 pi is also 0. So here sin pi is 0. Again, n equal to 5 means 225. So we can write it as what? 270 minus 45. 270 means it is in third quadrant. In third quadrant, sign value is negative, that's why we are taking here negative. And also 270 means sign is converting into cos, and 45 degrees means minus 1 by root 2. So these are the first 5 terms. Here is another problem, evaluate the limits. So find the limit value as n tends to infinity. These types of limits are called limit at infinity. For this limit at infinity problems, we have some logic here. Suppose what is the degree for the numerator here? 1, and degree for the denominator is 2. So degree of the numerator is greater than degree of the denominator, here n square. Then when you are taking common, what will happen? 1 by n will be there. So as n tends to infinity, 1 by n tends to 0. So 0 into anything is 0. So answer will be 0. That means what? When you are taking the degree of numerator is less than degree of denominator, then the answer will be 0. Let us see. See here, n common means we are taking 1 plus 5 by n. Here what is the highest degree, that we need to take as common, n square. Then what will happen? As n tends to infinity, this 1 by n is 0, 1 by n square is 0. When you are cancel off this one, then 1 by n will come. So 1 by n means as n tends to infinity, 1 by n tends to 0. So here this value is 0 into 1 plus 5 into 1 by n means 5 into 0 by 7 into 0. So 0 into anything is 0. So answer will be 0. So see here, for this problem, degree of numerator is equal to degree of denominator, then the answer will be coefficients of these values. Like what is the coefficient for n cube here? 1. Coefficient of n cube here? 4. So answer will be 1 by 4. 1 by 4. So how to do this problem? What is the highest degree n value? N cube. That's why n cube taken as common. Then n cube common means here 1. Here n square by n cube means 1 by n. Here by n cube. Similarly for the denominator. Now n cube gets cancelled. As n tends to infinity, here 1 by n cube terms are there. 1 by n square term is also there. That's why as n tends to infinity, when n is in the denominator, then the answer will be 0. So substitute all those values, zeros, and here 1 into. So what is the coefficient? Here what is remaining? Here 1, here 0, 0. Here also 4, 0, 0. This is 1 by 4. Okay, so what we observed here, if numerator degree and denominator degree is same, then the coefficient values are nothing but the answers. Coefficient of numerator by coefficient of denominator for the highest degree. Now see here. Here what is the highest degree in this? N power 5. What is the highest degree in this? N power 5. So can you guess the answer? Here n power 5 coefficient is 1. Here n power 5 coefficient is 2. So 1 by 2 is the answer. So how it is? Take n power 5, highest degree taken as common, then n cube by n square, like this will come. Here also n power 5 as common, then 1 by n, 5 by n power 5, here 2. So after taking as n tends to infinity, 1 by n tends to 0, 1 by n square tends to 0, 1 by n cube also 0, and 1 by n power 5 is also 0. Substitute here all zeros. Then what are the remaining things? 1 by 2 will be the answer.